This video is for the introduction to balancing equations. We're going to start with visualizing some molecules and learning what the coefficients mean, as well as counting atoms here at the bottom. So this first example is 3NH3. And the big circle in the middle is for our N, and these little ones around the outside of it are our H's. And if we draw 3 of them, we'll count the example as the first one, and then we'll draw 2 more. And then we'll simply count how many of each we have. So we call this an atom inventory. We have 3 N's and we have 3 H's on each for a total of 9. And being able to do this will help us balance equations. In the next example, we have 4 CO2. So the 4 is our coefficient. C is in the middle, and these circles on the outside are our O's. If we need 4 of them, we're just going to draw 3 more. And then we'll just count each element. So when we count our C's, we'll see that we have 1, 2, 3, 4. And each molecule has 2 O's. So we have 1, 2, 3, 4, 5, 6, 7, 8 O's. If we do 5 N2s in the third example, we've got, I'm going to draw down here since we're running out of space. We're going to draw this 5 times. And you can easily see that we have 10 N's. For the next 3 examples, you're going to try these on your own. Draw the number that it tells you to. Here we have 2, this one has 3, this one has 5, and then you're going to count your total for each atom, and then you'll see a slide with the right answers so you can check to see if you did it right. Here are the answers to the ones you tried on your own. Ask a neighbor or Mrs. M if you have any questions. Now I'm going to show you how we're going to start balancing equations. In the first equation, we have 2 NAs. So we're going to mark that inventory with a 2. For Cl2, we have 1 box of Cl2, but the subscript of 2 means our inventory is 2. On the other side, over here, we need to follow the law of conservation of mass, and we always start with at least 1. So I'm going to go ahead and draw one of these. And at this point, I see I have 1 Na and 1 Cl, and I need to keep adding boxes until I have the same on each side. So I'm going to draw another one. And now I can see that I have 2 NAs and 2 Cls, and this equation is balanced. In the next example, we have P, and we have 2 boxes. So we're going to draw P twice. We have a F2, so we're going to draw it exactly like that until we fill all the boxes. So we're going to draw it 5 times. On the other side, we have a formula of PF5. And I have to draw it exactly like that. I can't change the formula at all. On the left side, the reactant side, we know we have 2 P's. We have 5 boxes of F2, but each box has 2 F's, so I have a total of 10. I usually just pick an element to start with, so I'm going to start with P. And in one box of PF5, I have 1 P, so I know I need another. And when I have 2 of these, I count that I have 2 P's, and I have 5 plus 5 F's for 10 F's. And when I have the same number of P and the same number of F, I know that my equation is balanced. And the final step we're going to do on both of these right now, you count the boxes and they become coefficients. Sometimes that can be a little bit confusing. So I've got 2 boxes of Na here. That means I have a coefficient of 2. I only have 1 box of Cl2, so that's a coefficient of 1. And I have 2 boxes of NaCl, so that's a 2. On the next example, 2 boxes, 5 boxes, and 2 boxes. So we've got coefficients of 2, 1, 2 and 2, 5, 2. At this point, you may be ready to try some on your own, so feel free to stop the video at any time, give one a try, and then play it and see if you're right. That's the best way to learn. So we're going to fill in AlCl3 2 times and MgO 3 times. Go ahead and do your inventory on this side. We have 2, 6, 3, and 3. I know I need at least 1 box of everything, so I'm going to go ahead and get that started. And then I just pick an element to start with. I can see that my Al is good, so I probably don't want any more boxes of Al2CO3. I will go ahead and check O. This O, I have 3. That one's also good. I'm put a little check mark here by Al, check mark by O. Now we're ready to check Mg. On the reactant side, I had 3, and over here I only have 1. So I'm going to draw 2 more of these. And now I've got 3 Mg's and 6 Cl's. Every element is balanced. This equation is done. I simply count my boxes. 2, 3, 1, 3 are my coefficients. Moving on to the next one, we've got KClO3. We're going to write that twice. We'll do our inventory, 2 Ks, 2 Cls, 6 Os. On the product side, we're going to start with 1 of each formula. And I usually just go left to right, so we've got K here with 2. Product side, I only have 1. So I'm going to add another. Now I have 2 Ks and 2 Cls. Those are good. And now we're ready for O. The reactant side I have 6. The product side I have 2. I need a total of 3 of those to get to 6. And to get my coefficients, I've got 2 of these, 2 KCLs, and 3 O2s. For these last two, you're going to try on your own, and then, so you'll pause the video, and then you'll play to check your answers. Here are the answers to the last two examples. You might have felt like this one was a little tricky because you actually only needed one of each product. One Na2CO3, one CO2, and one H2O. And it's easy to see that there are two NAs. The H, there's two H's. But the C's, there's a C in the first box, and there's another C in the second box. That's where we get that too. And then the O's are in all three products, so you have to add them all together. There's 3 in the first box, 2 in the second box, and 1 in the third box for a total of 6. So the coefficients are 2, 1, 1, 1. And in the last example, we have 4, 3, 2.